Variable creation and labeling. In this video, you will learn how to create variables in IBM SPSS Statistics. Now that we have become familiar with the SPSS Data Editor interface, we are now going to practice creating variables. Creating variables is an essential first step in the development of any database before any data can be entered. We create variables in the Variable View window. To select the Variable View from the Data Editor window, as we did before, click on the Variable View tab in the bottom left-hand corner of the screen. As you can see, this window already has a defined structure, as there are 11 column headings. Each column heading is used to indicate a characteristic of the variable. Note that each row represents a potential variable. Let's start by creating a variable called age by typing age into the first column of the first row under name. Now, after typing in age into the first column of the first heading, click Enter. Now, as you can see, SPSS has already selected default characteristics of our variable under the remaining column headings. Let's go through each column heading before we enter more variables. The first column, as we have just seen, is our variable name. There are a few rules about creating variable names that we have to keep in mind. First, the name must begin with a letter. The remaining characters can be any letter, any digit, a period, or any symbol. Although variables can include a period, they cannot end with a period. Variable names that end with an underscore should also be avoided. The length of the variable name cannot exceed 64 characters, but it's good practice to keep variable names short and clear, as we did with age. Spaces and special characters like question marks or exclamation points cannot be used. Variable names must also be one word with no spaces. The underscore character is frequently used where a space is desired. The type column is showing a numeric, which is the default setting for type. This means that number values will be expected in the dataset related to this variable. This is correct for almost all variables you will create in a typical dataset, except in cases where you want to record a variable that indicates a date or answers from an open-ended question. For age, we would typically require that a number be entered representing age in years. Since that is the case in this example, we will keep the default setting under variable type. The variable width column deals with the maximum number of characters that will be displayed for a particular variable in all output related to this variable. We'll discuss output in a later video. For now, by default, the width value is set to 8. This is often appropriate and generally does not need changing. The next column, labeled decimals, indicates the number of decimal places that will be displayed in all output related to this variable. By default, the decimal is set to 2. Since our variable is age, we are only going to be working with whole numbers and do not require any additional decimal places. So let's change the decimal value to 0 by clicking on the cell under decimal and clicking on the bottom arrow until we get to 0. Then press Enter. You can also simply select the number in the cell and type in 0. The next column is headed Label and is used to inform SPSS about the details associated with each variable name. The maximum length of any label is 255 characters, and there are no restrictions on what may appear as with variable names. Variable labels are used to define what each variable stands for. Let's type in a label for the variable age. We want to tell SPSS that this variable means age of participant in years. So let's type in age of participant in years in the first cell under label. And push Enter. The next column heading is Value Labels. Since the numbers entered in age are to represent years of age, we do not need to label each numeric value that will be entered into SPSS. We will save that task for our other variables. The next column of our variable view sheet is missing. In the statistical analysis of any dataset, it is sometimes necessary to exclude cases where information is not known or not appropriate. An example of this occurs when data is missing due to survey skip patterns, when a respondent has failed to answer a question, or data is simply unavailable. A number that could not be expected as a genuine response is selected to represent these circumstances. Within SPSS, there are two types of missing values: system missing values and user-defined missing values. For user-defined missing values, this column of the variable view must be used. It is good practice to provide user-defined values to reduce error when entering data. Let's enter our user-defined missing value for the variable age. It is good practice to be consistent with our user-defined missing values. That is, we want to make sure it is the same for all variables in our dataset. To create our user-defined missing value, click on the first row under Values. Now click on the Call button on the right side of the cell. When the Missing Values window opens, you want to click on the Discrete Missing Values button. As I stated before, we want to use a value that cannot be expected to be a genuine response to any of the items in our dataset. Let's type in -99 to represent missing values, as there are likely no items in our dataset that could have a genuine response of -99. After you've entered in -99 under Discrete Missing Values, click OK. Notice that -99 now appears in the missing column for the variable age. The next two columns, Columns and Align, are concerned with the display of data in the Data View window. The default values of a column 8 characters wide and the value right aligned are fine and rarely need changing, so we'll leave them alone for now. The Measures column is concerned with the measurement scale properties of your variable. In statistics, certain procedures are only appropriate for variables measured on a specific scale of measurement. The measurement characteristics recognized by SPSS are as follows. Scale is selected for numeric variables that can take discrete or continuous values along a range. Income and age are good examples. Ordinal is selected for variables that have values that are numeric but represent an ordered listing. This is generally true for Likert scale questions. Nominal is selected for variables with values that are simply named with no hierarchical order. Variables such as race, religious orientation, or sexual orientation are good examples. Since our variable age represents a variable with discrete number values, we will select Scale by clicking on the Measure cell for age and clicking on Scale. As you can see, Scale is now displayed under the Measures column of the variable age. The last column is Role. This is one of the newer features in SPSS, and there are very few procedures which require role to be edited, so we will leave all variables as the default role of input. Congratulations! We have created our first variable age in SPSS. Age is one of an infinite number of variables that you can create. For the most part, variables will have different characteristics and properties, and we'll practice creating specific variable types that you will have to know before beginning any type of analysis. Now that we've practiced creating a scale variable such as age, let's create the categorical variable sex to represent reported biological sex of participant. As we did with age, let's create a name by typing in the word sex under the name in the second row. And press Enter. Under Type, we will allow the default of numeric to remain, since we will be designating numbers to represent our categories of sex. We will do the same for width. Let's remove the decimal places, since we will only need discrete numbers to represent our values for sex. Again, click on the cell under Decimals and click on the bottom arrow to bring it down to 0. Under Label, let's type in a definition of our variable, which will be reported biological sex. For values, we will need to code each one of the values that represent different categories of sex. Specifically, we want values for male, female, and other. To do this, we must first begin by accessing the Value Labels option box by clicking in the value cell for our sex variable and clicking on the Call button on the right side of the cell. Let's try it. As you can see, the Values Labels option window has appeared. This options window includes a space to fill in values and labels. Let's start by labeling our code for female. First, we must decide the number for our female code. Recall that for each one of our categories for sex, we have to tell SPSS what categories are represented for each numeric value. For our sex variable, we will designate 1 for female, 2 for male, and 3 for other. Let's begin by typing 1 in the values box. Now press Tab to move the cursor to the Labels box. Now let's type in our first label, female. After you are satisfied with your variable value and label, click on the Add button. Now that we've entered in our first value code for female, let's enter our value code for male at 2. And we type in male into the labels box. Click on Add. We type in 3 for our others category. And then click on Add. Now click on OK. As you can see, the values are now partially displayed under the values column of our sex variable. We have now defined our value codes for SPSS regarding sex. Now let's type in our missing code. Recall that we want to be consistent with the missing codes in our dataset. So let's repeat the procedure we did with age and type in -99 under the discrete missing values. As before, we'll leave columns and a line alone for now. Under Measure, we must tell SPSS to recognize this as a nominal variable since there is no hierarchical order between male, female, and other. As before, let's click on the cell for measures and finalize our first categorical variable.